I'm going to do this in two parts. So this is part 1. So the directions for this first part says use reciprocal or quotient identities to find each exact value. So it's telling me to do this a specific way. I'm looking for cosine. I have cotangent and I have cosecant. Well, I know cotangent is cosine over sine, and I know that cosecant is the reciprocal of sine, so sine x would be equal to negative 1 over 5 square root of 2. So knowing that, and I don't care that it's rationalized because it's not the end part of my question. So cotangent, which is negative 7, cotangent is cosine, which I don't know, over sine, which is negative 1 over 5 square root of 2. So then I want to get cosine by itself, so I'm going to multiply both sides by the denominator. So when I multiply this by that negative 7, I'll make it positive 7 over 5 square root of 2 equals cosine x. And then when I rationalize, I'm going to get that cosine x equals 7 square root of 2 over 10. Okay, number 2, I want to find tangent if I have secant and sine. So tangent is sine over cosine. Secant is the reciprocal of cosine. So cosine theta is going to be negative 5 over 9. So now I have sine and cosine. So tangent theta, which is what I need, is equal to sine, which is 2 square root of 14 over 9 over cosine, which is negative 5/9. Now I'm going to multiply by the reciprocal. Did not do that here because I wasn't trying to simplify this. I was just multiplying both sides. But here I have a fraction and a fraction. I'm going to multiply by the reciprocal. So that's 2 square root of 14 over 9 times a negative 9 over 5. Those cancel out. And tangent theta is equal to negative 2 square root of 14 over 5. All right, number 3. Now these directions say use Pythagorean identities. It specifically says to do that. So I have secant. Secant is negative. Sine is positive. So when secant is negative and sine is positive, that means we are in the second quadrant. That's important because I need to find the cotangent, and in the second quadrant, cotangent is negative, so I need to make sure that I use that. So I want cotangent. I can find tangent if I have secant, and then I can use the reciprocal. So I think I'll do that one. So using my Pythagorean identities, I know that tangent squared alpha plus 1 equals secant squared alpha. So that's negative 5 square root of 6 over 12 squared. So that's tangent squared alpha plus 1 equals, so it's going to become positive. Then I'm going to get 25 times 6 up there over 144. And then when I simplify that, because 6 goes into 144 24 times, so this is going to actually give me 25 over 24. So tangent squared alpha plus 1 equals 25 over 24. I'm going to subtract 1 from both sides, so tangent squared alpha is going to equal 1 over 24. So I take the square root of both sides, and tangent of alpha is equal to plus or minus the square root of 1 over 24. So then the reciprocal of that, and again, I'm in the second quadrant, so I actually want the negative 1. And so this is like the square root of 1 over the square root of 24. Then cotangent of alpha is equal to negative square root of 24 over 1. And when I simplify that square root, I get negative 2 square root of 6. So number 4, I have tangent. Tangent is positive. Secant is secant is negative. So that means I'm in quadrant 3, and I need sine. Okay, so tangent, if I use the Pythagorean identities, can give me secant. And then if I have secant, I can find sine. So I'm going to have to do this one in 2 steps. So to use my tangent squared, so tangent squared plus 1 equals secant squared. So 17 equals secant squared alpha. And so secant alpha is equal to negative square root of 17, which means that cosine alpha, cosine of A equals negative 1 over the square root of 17. Don't care about rationalizing because it's about to get squared anyway. So now I can use the other Pythagorean identity that I have, which is sine squared A plus cosine squared equals 1. So sine squared A plus 1 over 17 equals 1. So sine squared A equals 16 over 17. Sine A is equal to plus or minus the square root of 16 over 17. And again, I'm in the third quadrant, so I know it's going to be negative. So that's negative 4 over the square root of 17. Then once I rationalize that, get negative 4 square root of 17 over 17. Are there other ways to work these problems? Yes, but it says use Pythagorean identities. All right, so then this one says use the cofunction and even and odd identities to find each value. So I want to find secant of y minus pi halves if I have the cosecant. All right, so I know that secant of y minus pi halves is equal to the secant of negative pi halves minus y. Then secant of negative theta is equal to secant theta, so this equals secant of pi halves minus y. Secant of pi halves minus y equals cosecant, okay? So that's equal to negative 1.08, and that is secant of y minus pi halves. Okay, number 6. Tangent of pi halves minus beta equals 0.37. Well, tangent of pi halves minus beta is cotangent beta, so that equals 0.37. But I need cotangent of negative beta, so I'm going to multiply both sides by a negative 1. So negative cotangent beta equals negative 0.37. Then negative cotangent beta is cotangent of negative beta, and that is negative 0.37. So here I want to find the exact value of each trig expression. Well, the cosine of pi 12ths is not anything that I know or that you know or that you're expected to know. But if I double that angle, it becomes pi 6th, and I do know what to do with pi 6. So that means I need to treat this as the half angle. So theta over 2 is equal to pi 12ths, which means theta is equal to pi 6ths. So when I look at my half angle identities, I have cosine of theta over 2. So cosine of theta over 2. And to use that one, I have to know what the cosine of theta is. This is theta. The cosine of pi 6ths is square root of 3 over 2. So in this is plus or minus the square root of 1 plus cosine, square root of 3 over 2, all over 2. So in the numerator, I'm going to get a common denominator. So this equals, and I can drop this plus or minus because this is what I want the cosine of. This is in quadrant 1, so this is going to be positive. So the square root of, in the numerator, to get a common denominator, this has to become 2. So 2 plus the square root of 3 over 2, all over 2. And then I can make that 2 over 1, it's all under the square root, multiply by the reciprocal, so I get the square root of 2 plus the square root of 3 over 4. So then I can take the square root of the denominator, and that's the square root of 2 plus the square root of 3 over 2, and that is the cosine of pi 12ths. So do the same thing for the sine. Now this is sine of negative 23 pi over 12. So I have to figure out which quadrant that is in. If I'm going negative, I'm going around this way, right? To go all the way around to 2 pi, that would be 24 pi 12ths, so that 23 pi 12ths lands me in the first quadrant. So theta over 2 is equal to negative 23 pi over 12. So then theta is negative 23 pi over 6. So I'd like to figure out what that coterminal angle is. And in order to do sine of the half angle, I have to know cosine again. So cosine of negative 23 pi over 6. So cosine of negative theta is cosine of theta. So it's the same as the cosine of 23 pi over 6. And then to get the coterminal angle for that, that's 11 pi 6. Okay, and then the cosine of 11 pi 6 is square root of 3 over 2. Okay, so then the half angle, the sine of the half angle. Using that identity, that's equal to plus or minus the square root of 1 minus the cosine over 2. So again, I'm in quadrant 1, so it's definitely going to be positive. You get a common denominator in the numerator, so this is going to be 2 minus the square root of 3 over 2 all over 2. Then I'm going to multiply by the reciprocal, so I get the square root of 2 minus the square root of 3 over 4. I can take the square root of the denominator, so that's the square root of 2 minus the square root of 3 all over 2, and that is the sine of negative 23 pi over 12. All right. On the back, I want to find the exact value here. So I have cosine, and I know that theta is between 0 and pi halves. So it's in the first quadrant, and I want tangent of 2 theta. So for my double angle for tangent of 2 theta, I have to know what tangent theta is. So I need to draw a picture here to figure that out. I know I'm in the first quadrant because of this. So draw my triangle in the first quadrant. Cosine is adjacent over hypotenuse. Do Pythagorean theorem, you're going to get 2 square root of 2 for this side. So when I go to substitute this in, tangent of 2 theta equals, is going to be 2 times tangent theta. So tangent is opposite over adjacent, so that's just 2 square root of 2 over 1 minus 2 square root of 2 squared. So in the numerator, that's going to give me 4 square root of 2. Denominator, that's going to give me 1 minus 8. So I get tangent of 2 theta equals 4 square root of 2 over negative 7. So it makes the whole thing negative. All right, so I have the tangent. I need sine of 2 theta. So to do that, that's 2 sine theta cosine theta. So I need sine and cosine. And I can't just take the pieces out of that. That does not work that way. This is not a unit circle. So I'm going to draw my picture. The triangle is between pi halves and pi, so we're in the third quadrant. Tangent is opposite over adjacent, and this is the one that's negative. Do Pythagorean theorem, you're going to get 11. So sine of 2 theta, again, is 2 times sine theta cosine theta. So sine is opposite over hypotenuse, 6 square root of 2 over 11, times cosine, which is negative 7 over 11. So I can't reduce the 2's with the denominators there, so that means I just got to multiply all this together. The denominator is going to be 121, and the whole thing is going to be negative. And so I have 7 times 6 is 42, and double that, I get 84 square root of 2 over 121. There we go. So tangent of 3/8. Again, not a value I know, so we're back to thinking about the half angles. So if theta over 2 equals 3 pi 8ths, then theta is 3 pi 4ths. And for tangent, I need tangent of 3 pi 4ths. So the tangent of the half angle is equal to 1 minus the tangent, so that, I'm sorry, not the tangent, cosine. I actually have choices for theta over 2. So I'm going to do the, for tangent of the half angle. So I'm going to do the second one, the 1 minus cosine. So the cosine of 3 pi fourths is negative square root of 2 over 2 over the sine, which is a positive square root of 2 over 2. So this in the numerator becomes 1 plus, but I'm going to get a common denominator in the numerator. So this has to become 2. So I'll get 2 plus the square root of 2 over 2 all over square root of 2 over 2. Then I'll multiply by the reciprocal. So 2 plus the square root of 2 over 2 times 2 over square root of 2. So these two cancel out. That leaves me with 2 plus the square root of 2 over 2. So when I rationalize and I multiply it by the square root of 2 over the square root of 2, I have to distribute this to both of them in the numerator, so I get 2 square root of 2 plus 2 all over 2. Then I can factor out a 2 in the numerator. 2 down here, those cancel out. So I get square root of 2 plus 1 equals tangent of 3 pi eighths. All right, cosine of 7 pi twelfths. Well, theta over 2 is 7 pi twelfths, so theta is 7 pi sixths. To do cosine of a half angle, I have to know the cosine. So cosine. All right, so cosine of theta over 2 equals, so this is plus or minus the square root of 1 plus, so the cosine of 7 pi 6 is negative square root of 3 over 2 all over 2. Okay, and so I have to decide if it's plus or minus. 7 pi twelfths is definitely in the second quadrant because 6 pi twelfths will be pi halves, so it's a little bit past that. So I'm in the second quadrant, which means this one is negative. Negative square root of 1. So when I get a common denominator up here, it's going to be 2 minus the square root of 3 over 2 all over 2. When I multiply by the reciprocal, I get negative 2 minus the square root of 3 over 4, which means that cosine of 7 pi twelfths equals negative square root of 2 minus the square root of 3 all over 2. All right, 15. I've got tangent of beta, and beta is between 3 pi halves and 2 pi. And I need to find the cosine of the half angle. So in order for me to find the cosine of the half angle, I have to know the cosine of the angle. So from this, I'm going to need a little picture. And this one, the reason it tells me this, beta is between 3 pi halves and 2 pi, that means my triangle is in the fourth quadrant. That's important so I get the signs on the numbers correctly. Tangent is opposite over adjacent. So this is negative. I do Pythagorean theorem, and I'm going to get 6 right here. Now, I need to figure out what quadrant I end up in. So remember, this is beta. I need to know where beta over 2 is. So if I divide that by 2, I have to divide each one of these by 2. So that means that the half angle is between 3 pi fourths and pi. So that's going to put me in the second quadrant. So my final answer is actually in the second quadrant. Then I substitute this in. Cosine of beta over 2 equals, well, it's not plus or minus, it's just minus because I know I'm in the second quadrant, square root of 1 plus 5 over 6 all over 2. So that is negative square root of, that's going to be 11 sixths over 2, which is negative square root of 11 over 12. When I rationalize, I'm going to get negative square root of 11 over 2 square root of 3. Still can't leave it like that. Got to rationalize again and get negative square root of 33 over 6. That is the cosine of beta over 2. All right, so I have cosine, X is between pi and 3 pi halves. That puts me in the third quadrant. So I'm going to need a little picture here. So in the third quadrant, here's this. Cosine is 2 square root of 6. This is 5. Do Pythagorean theorem. That's negative. This will be negative 1. So tangent of the half angle. So here, I know that X is in the third quadrant, but the half angle X over 2, this would be pi halves, that'd be 3 pi fourths. So I'm between pi halves and 3 pi fourths. So I'm in the second quadrant when all is said and done. So I'm going to find tangent of the half angle. I have options for that. I'm going to use the second option again. So this is going to be 1 minus cosine, which is a negative 2 square root of 6 over 5, all over the sine, which is negative 1/5. In the numerator, I'm going to get a common denominator. So this is going to be 5 plus 2 square root of 6, all over 5, over negative 1/5, multiplied by the reciprocal, and the tangent of the half angle is negative 5 minus 2 square root of 6. All right, so now I'm going to simplify these expressions. Got some options here. Cosecant and cosine are not reciprocals of each other, but I do have a GCF. So I'm simplifying. I need an equal sign. I can't just have random stuff. I'm going to factor out the GCF. I need parentheses. This is cosine squared a minus 1. Right? So then to substitute for cosine squared a minus 1, I can substitute negative sine squared a. So cosecant and sine are reciprocals, so I know that it's 1, or in this case negative 1, but if you need to actually see it, the reciprocal of cosecant is 1 over sine squared a times negative sine squared a. Then you can think of that as over 1. Those cancel out, and your answer is negative 1. All right, so 24. In the numerator, I don't have any desire to do any reciprocals or quotients yet until I can see if I can clean up that. That is a difference of squares. So that very simply is equal sign cosecant squared theta minus cotangent squared theta all over sine theta. So I could do reciprocals and quotients here, but I know how cosecant and cotangent are related. Cosecant squared is cotangent squared plus 1. Okay, so I'm substituting that in, minus cotangent squared theta. Oh, I forgot my theta. All over sine theta. So here, I substituted something with more than one term, so I use parentheses, but they don't really do anything. These two zero out, so I'm left with 1 over sine theta, which is cosecant theta. So number 25. I have two double angles in here. I need to substitute them both, but I am not going to do them at the same time. I have options for this one. So I don't have options for this one. I'm going to do this one first and then see if that helps me decide on what I want to do with this. So this is going to be 1 plus cosine of 2x over, then cosine of 2x is 2 sine, sine of 2x is 2 sine x cosine x. So I'm thinking that I would like for that 1 to be able to go away. So if I look at my options for cosine of 2x, I've got two of them that have 1s in them. And the one that I could substitute in that would help that 1 0 out is the the 2 cosine squared x minus 1. So this is going to be 1 plus, and then I got 2 cosine squared x minus 1 all over 2 sine x cosine x. So these 1s 0 out, and then that leaves me with 2 cosine squared x over 2 sine x cosine x. The 2's cancel out. This cosine cancels out with one of those, so I get cosine x over sine x, and that becomes cotangent x. All right, so number 26. I've got to substitute the sum and difference of angles. So I'm getting all of this stuff straight from my reference chart. So this becomes cosine A times cosine B minus sine A sine B plus cosine A cosine B plus sine A sine B. Then I'm going to substitute all of this stuff in the denominator. This gives me sine A cosine B minus cosine A sine B minus, now I'm subtracting something with more than one term, so I need parentheses, sine A cosine B plus cosine A sine B. All right. So then I'm going to simplify. I've got cosine A cosine B, cosine A cosine B, so that is 2 cosine A cosine B. Then minus sine A sine B plus sine A sine B, those zero out. So I'm done with the numerator. Sine A cosine B minus sine A cosine B, those zero out. Then negative cosine A sine B minus cosine A sine B is going to be minus 2 cosine A sine B. Then the 2's cancel out. The cosine A's cancel out. That leaves me with cosine over sine, and that is going to be a negative cotangent B. That is the end of part 1.